So today we will discuss about elements of communication system. So this is the general block diagram of a communication system. Okay, this is the general block diagram. The first block is information source, next is transmitter, then channel, receiver, destination. In the channel we have noise source, noise affection. Okay, so this is actually the general block diagram of a communication system. First one is information source. So what is the communication system? What is the need of a communication system? Communication means we need to transfer information. Okay, communication means exchange of information. We need to exchange information for a distant place. You are in some place and your friend is in somewhere longer distance. You have to transmit a message or you have to send an information. So you need a communication system. So first is the information source. Okay, so this information source can be a text message, a voice signal, okay, anything. Okay, so or an image like that. That is the information source here. Okay, so that you have to transmit it to a destination. Okay, and the source and destination are kept at a far distance. Okay, so what you have to do, you have to design a communication system. So this is the general block diagram. So in this information source can be message or a voice or an image. First you need to convert this information, this signal, this voice or a message or text message or image, all those things are non-electrical signals. Okay, you have to convert that physical quantities into electrical signal. For that you need a transducer. So in this information source we have transducer which convert the information into electrical signals, and then we need to transmit that in electrical signals. So for that we need a transmitter. What are the things in a transmitter? In a transmitter actually you have an amplifier. In a transmitter actually you have an amplifier, modulator, filter, antenna, mixer. These are the things which you can see in a transmitter. What are they? An amplifier, modulator, filter, antenna, a mixer circuit, like that. Those blocks are there in this transmitter. Okay, so first the electric, here we comes the electrical signal. We reaches the electrical signal here. So it is a low frequency signal. This signal is actually low frequency, low energy signal. Okay, we need to transmit this signal into a far distance. So this low frequency signal should be converted into a high frequency signal. Okay, so this low frequency should be converted to high frequency. For that we need a modulator. So for that we need a modulator. This modulator converts the low frequency signal into high frequency. Okay, through modulation process. And that modulated signal is having low energy. To increase the energy we use an amplifier which amplifies the signal to get amplifies and boosts the signal to a sufficient energy level. Okay, now it is properly filtered and it is transmitted to a channel. Okay, how to transmit a signal, electrical signal? Definitely we need an antenna. So after transmitter, here actually we have an antenna system. Here actually we have an antenna system. So this electrical signal is fed to this antenna, and this antenna transmit the signal. And how it is transmitting? Through which medium it is going? Through a channel. Channel can be wired or wireless. So in wired we have optical fiber cable, coaxial cable, like that. But in wireless communication we have free space as the medium. So this antenna transmitting information to the free space through, and that transmitted wave is called EM wave. Okay, electromagnetic wave. This electromagnetic wave is transmitted over this channel. And what is the properties of that signal? That transmitted signal from the antenna, it is an EM wave, and that wave is actually high frequency, high energy. Okay, it is high frequency, high energy. Why? Because after modulation the frequency is increased, so it is high frequency. Amplifier boosts the signal, power amplifier boosts the signal, so it is energy is high, so it is high frequency, high energy signal we are transmitting. But the problem is the destination is a far distance. The signal has to travel a long distance. Okay, After traveling a long distance, its energy will get decreased. Okay, its energy is going continuously going. Why? Because it's traveling over a long distance, and this free space is contained. Free space have a lot of obstructions. Okay, dusty particles, snow particles, buildings, all those things, reflection, all those process happens. Distortions occurs. All this, with the effect of all this, its energy is getting decreased. Okay, and one more thing is this free space have a noise affection. Different noise signals are entering into this channel. Channel is nothing but free space, so definitely there will be noise. So due to this noise also the signal get affected with this noise, and this energy is decreased. Okay, so after it will travel a long distance, and after it will reaches to the receiver. Okay, so what are the things in a receiver? Receiver have an amplifier system, a demodulator. Here we have a modulator and amplifier. Here we have a demodulator and an amplifier. Of course, we need an antenna system here to receive the signal. Why? Because the received signal is EM only, electromagnetic signal. We have to convert the EM wave into electrical signal. For that, we need an antenna. The antenna receives the EM wave and it will convert it to electrical signal, and it is given to the receiver. Receiver have an amplifier system. Why? Because the received signal is high frequency but low energy signal, and that energy should be boosted. So for that we need an amplifier system which will boost the energy of the received signal. And then demodulator. Why demodulator? We need to, our original message is low frequency only, but here we modulated to high frequency and transmitted. So here we need our original signal. For that we need to demodulate the signal to low frequency. High frequency signal is demodulated to low frequency. So we need a demodulator here. Then demodulator demodulates the signal to low frequency. So the received signal after demodulation you will get a high energy low frequency signal. Okay, and filter circuit is also here in this receiver block. Why? Here noise is added to this channel, so signal is affected with this noise. So the noise should be filtered out. For that we need a filter circuit in this receiver block. Okay, so after filter out we will get a low frequency high energy signal, and that is given to the destination is nothing but our system, our unit, receiver unit. Okay, so it finally, suppose you are sending a voice signal, you need a speaker to hear the voice. So here it is electrical signal. That electrical signal should be converted into physical quantity. Again you need a transducer here. Okay, so it will convert the electrical signal into non-electrical signal or a physical quantity that we can measure or hear or we can see, like that. So this is actually the complete block diagram and element of a communication system. So while writing you have to write all those things in detail. What are the things in transmitter? You have a amplifier system, modulator, filter, and an antenna, mixer. Okay, mixer and modulator. Mixer is also a part of modulator, which is used to up convert the frequency or increase low frequency should be converted to high frequency. For that we need a modulator and a mixer circuit. Here we have a antenna, then demodulator, amplifier, demodulator, filter, all those things there in the receiver. Okay, so this is the complete setup of a communication system block diagram and its elements. Next we need to study the frequency bands and frequency spectrum. This is the frequency spectrum. Okay, the entire frequency is divided into different frequency bands. What is a spectrum? It is actually an allocation of different set of frequencies. Okay, starting from 10 raised to 0 to 10 raised to 21, this is actually the spectrum, and these are the different frequency ranges. And in this spectrum it will show what are the different application for different frequencies what we will use. Okay, for a particular frequency what is the application, like that it is written in the spectrum. Spectrum is actually nothing but a set of frequency, and that set of frequencies which we used for a particular application. Okay, it is fixed. Look at here, 10 raised to 0, 10 raised to 1, like that it is going, and up to 10 raised to 12 we can call it as radio frequency band. After that we can call it as optical frequency band. Okay, 10 raised to 6 we normally use for AM radio, 10 raised to 7, 8 range we normally use for TV and FM broadcasting, and these are comes under terrestrial microwaves. Okay, this 10 raised to 6 is normally megahertz, 10 raised to 9 gigahertz. This 10 raised to 9, above 10 raised to 9 gigahertz range, this range we call it as terrestrial microwave signals. Okay, microwaves are tiny signals or micrometer range signals, millimeter wave signals. Okay, so this area comes under terrestrial microwaves. Satellite and radar is also comes under 10 raised to 11 to 10 raised to 12. 10 raised to 13, 14 range we have infrared, then 10 raised to 15 visible, 10 raised to 16, 17 range ultraviolet, then X-ray, gamma ray, cosmic ray. Okay, 10 raised to 18 range X-ray, 10 raised to 18, 19 range X-ray, 10 raised to 20 range gamma, 10 raised to 21 hertz frequency range cosmic rays. This is the frequency range. So these are the different frequencies which we used for different application. Here AM and FM, radio, TV, broadcasting, all those things comes under 10 raised to 6 to 10 raised to 8, 9 range. These are the frequency. Okay, 10 raised to 5 hertz, 10 raised to 6 hertz, 10 raised to 7 hertz, like that. Satellite and radar comes under 10 raised to 9, 10 raised to 11, 12 range. Infrared, these things normally we call as radio frequency band, which we normally used. Infrared, ultraviolet is another set of band. Okay, so now we will see what are, this is the spectrum. Now we will see what are the different frequency band allocation. Band number 2 is called 30 hertz to 300 hertz. Band number 2 is 30 hertz to 300 hertz. That is extremely low frequency, called as ELF, extremely low frequency. Band number 3, 0.3 hertz to 3 kilohertz. So band number 2, it is 30 hertz to 300 hertz, extremely low frequency. Band number 3, 0.3 hertz to 3 kilohertz. It is VF, voice frequency. This normally it is telephone communication, landline phone communication. No, for that we use this 3 kilohertz. Normally we call 300 hertz to 3 kilohertz. 0.3 hertz to 300 hertz we call it as, or 3 kilohertz we call it as voice frequency. Okay, so voice communication now we normally use 3 kilohertz. Next, band for 3 kilohertz to 300 kilohertz, it is very low frequency. Then band 5, 30 kilohertz to 300 kilohertz, low frequency. Band 6, 0.3 megahertz to 3 megahertz, it is medium frequency. 3 megahertz to 30 megahertz, high frequency. 30 megahertz to 300 megahertz, very high frequency. 300 megahertz to 3 gigahertz, ultra high frequency. 3 gigahertz to 30 gigahertz, super high frequency. Then 30 gigahertz to 300 gigahertz, extremely high frequency. Here we have extremely low frequency, here we have extremely high frequency. 12th band 0.3 terahertz to 3 terahertz, it is infrared light. 3 terahertz to 30 terahertz, infrared again. 30 terahertz to 300 terahertz, infrared again. Then 0.3 picohertz to 3 picohertz, visible light. 3 picohertz to 30 picohertz, ultraviolet. So here these are the infrared range. Okay, terahertz range are infrared range, petahertz range are visible light. Okay, here band 50, 0.3 petahertz to 3 petahertz means visible light. 3 petahertz to 30 petahertz is ultraviolet. 30 petahertz to 300 petahertz, X-rays. Okay, and now last 18th 0.3 exahertz to 3 exahertz, gamma rays. 3 exahertz to 30 exahertz, it is cosmic rays. Okay, these are the frequency band. This PHZ is nothing but petahertz, EHZ is nothing but exahertz. Okay, ELF is nothing but extremely low frequency. This includes AC distribution, AC power distribution of signal 60 hertz and low frequency telemetry signals. Extremely low frequency is used for AC power distribution. Okay, VF is voice frequency, and voice frequency is used for human speech, standard telephone channels. Okay, this for this application we use voice frequency. Its bandwidth is 300 hertz to 3 kilohertz. Okay, This bandwidth is allocated for voice channels. Next is very low frequency. Upper end, very low frequency upper end is human hearing range. We know very low frequency human hearing range is 20 Hz to 20 kilohertz. Okay, so that upper range is that VLF upper range എന്ന് പറയുന്നത് that is hearing range ആണ്. Okay, human hearing range ആണത്. Then special again it is used for specialized government and military systems such as submarine communication. Submarine communication നമ്മൾ very low frequency ആണ് യൂസ് ചെയ്യുന്നത്. Why? Because this signal have to travel a long distance. Low frequency അതായത് സബ്മറൈൻസിൽ നിന്ന് വരുന്ന സിഗ്നൽസ്, യു നോ വാട്ട് ഈസ് എ സബ്മറൈൻ. സോ ദറ്റ് ഈസ് സിഗ്നൽ ഷുഡ് ബി, അപ്പോൾ അത് യൂസ് ചെയ്യുന്ന ടെക്നോളജി ഇച്ചിരി കുറച്ച് ഓൾഡ് ടെക്നോളജീസ് ആയിരിക്കും. ഓൾഡ് മീൻസ് വെരി ലോ ഫ്രീക്വൻസി സിഗ്നൽസ് ആണ്. അപ്പം ഒരു അത്രയും സോഫിസ്റ്റിക്കേറ്റഡ് ആയിട്ടുള്ള എക്യുപ്മെൻറ്റ്സ് വേണം we need to track that signal, and that signal has to travel a long distance also. Okay, next is low frequency marine and aeronautical navigation. We use low frequency. Then medium frequency AM radio broadcasting. Medium frequency, you know what is medium frequency AM broadcasting. We use medium frequency, normally 535 kilohertz to 1605 kilohertz. High frequency, it is short waves, mostly two-way communication. We use this range. Okay, high frequency, that is short wave communication, mostly two-way communication, use this range. Okay, now in Voice of America and radio frequency Europe broadcasting in high frequency, all those for application they use this high frequency. Amateur radio, okay, citizens band, these are things in America they use high frequency. Then it is VHF. VHF is a mobile radio marine. Application of VHF is mobile radio, marine, aeronautical communication, frequency, FM broadcasting, commercial television broadcasting of channels 2 to 13. Okay, 54 MHz to 216 MHz, channel 2 to 13, commercial television broadcasting, we use VHF. Next is UHF. UHF is for again commercial TV broadcasting of channel 14 to 83, landline mobile communication, cellular phones, certain radar navigation systems, microwave satellite radio system. For those things we use UHF. What is super high frequency? SHF, microwave and satellite radio communication, very important. Okay, next is EHF, 30 GHz to 300 GHz, used for radio communication except in very sophisticated, expensive and specialized application. Okay, 30 GHz to 300 GHz is normally used for radio communication except in very sophisticated and expensive and specialized application. IR, EM radio waves radiation generally associated with the heat, used in heat seeking guidance system, electronic photography and astronomy. So IR is normally EM radiation generally associated with the heat, and it is used in heat seeking guidance system, electronic photography and astronomy. For all those things we use IR. And visible light, normally light communication, optical fiber communication, we use this visible light. So this is the frequency bands and frequency spectrum. So you have to study this frequency bands and spectrum.